Before I go on to the strange shape graphs, I thought we would do one with, again, a straight line, but a straight line coming down like that. What is that? What would that be? Well, again, it's a position time graph, so I'm going to put x up here and t down here. And so what this is saying is that, let's put some numbers up here. Be nice if I had graph paper, right? All right, so again, what's happening here is this object, or this guy, and again, I'll show my little diagram of the guy standing. So here's the 0 meter mark, and here's the 30 meter mark. And last time he was walking from here and going there. This time he's starting from here and now moving back this way. So I mean, that's his motion. And I mean, physics is full of any kinds of motion, so you need to be able to describe any kind of motion. So that's the only difference. He's going at the same speed, looks like, 6 meters at 30. So, you know, the slope is 5. Again, next time we'll use a different number maybe. So all that's happening different is that he's going this way instead of previously he was going that way. Okay, and the graph clearly shows it. He is coming towards the origin, right? He's going this way because time only goes this way. Do whatever you do, you can't make time go the other way. It's just, but you know, in physics, you could predict that, hey, if you were here now, I could tell you where you were earlier and where you were earlier and where you were earlier and where you were earlier, right? Again, you could do this mathematically too. So here we just see that the object is again moving at a constant speed because the slope is constant. And of course, if you took the slope now, you'd again get 5 as the magnitude, but again, you know, it'd be -5 would be your slope. And what does that negative mean then? Well, negative just means that instead of going to the right, you're going to the left. In physics, the right is always positive and upwards is always positive. We like to kind of keep up with the math guys, you know, because again, remember, math is the language. So this is always positive and that's always positive. Now you don't have to, you could always say, I want to make that positive, and you could do it that way. And if you kept everything together straight, you still get the same right answer. The two negatives would cancel each other out or would not even appear in some cases. But this is a convention we're going to primarily follow. Positive this way. So all that negative, so all that means is that my speed, or my velocity in this case, was -5 meters per second. Okay, so I know I kind of use the word velocity a little bit ahead of time, but velocity is just speed with direction. And that negative sign just means the direction. If it's positive, that means you're going 5 meters per second that way. If it's negative, that means you're going 5 meters per second that way, right? Just like these graphs here, okay? And so you might say, hey, well, how are you going to show this mathematically? Well, let's just use the same stuff we know from algebra, right? How would you write an equation that looked like this? So your y-intercept is 30, so it's going to put a 30 up there. And then, you know, this is 5t, but it'd be -5t is your speed, and so that's your x of t. See what I'm saying? Here's your m, which is your slope, -5. There's your t, which was your x, you know, like basically from y equals mx plus b, but again, we're looking at, you know, where x is now t. And here's your y-intercept. And just like that. And going ahead, you'll see that it's kind of cool that if I told you that there's one car going this way, another car coming down this way, that means that you're at the 0 meter mark and he's at the 30 meter mark and he starts driving. I'm going to show it here so you don't look at it, that it's all necessarily going that way. So here it is. So one car heads this way, one car heads this way. They don't have to have the same speed. They could have different slopes. And so where is it that they actually are going to cross each other? And that's where their position is in the same place and their time is the same. And so it would happen right there. And so it'd be a cool way to figure out, you know, I mean, I'm talking about a train leaves from Los Angeles and another one leaves here from, say, Santa Fe. And where is it that they're going to meet if this one's going at 80 miles per hour and this one's going at 60 miles per hour? Really be setting up two equations and solving them. Really, really simple once we get to those, if we need to. But right now, I just wanted to kind of show you motion graphs and show you how they work. And now we're going to move on and look at some simple different shape on these.